Welcome back. We're going to work on section 4.4 again today. So far in 4.4 we have looked at solving equations, exponential equations where we could get a common base. And then we looked at exponential equations where we couldn't get a common base, but we were able to take the log of both sides. One side had an exponent. Today our topic involves needing to take the logs of both sides, but our equation has powers on both sides. So we're still going to use common log. I'm going to take the log of each side. And I always use common log unless there's an e in the problem, then I would use natural log. What's different about today's stuff though is we have this extra power on this side. So when we think about expanding these and we say our powers move to the front, we now have an x minus 2 that's going to move to the front, get multiplied to the log of 5. But the same thing's going to happen on the other side. We've got this power that has to move to the front. So 2x plus 3 is now getting multiplied to the common log of 4. And in order to solve this, we're going to have to distribute. So I'm going to take x times log 5 minus 2 times log 5. When I distribute on the right, I get 2x times log 4 plus 3 times log 4. And then the trick to solving these is we want to get any of the pieces that have a variable with them, so any of the pieces that have an x, we want to move them to one side, and anything that doesn't have an x, we want to move to the other side. So I'm going to bring this 2x log 4 over to the left, and I'm going to move the negative 2 log 5 over to the right. So we end up with x times log of 5 minus 2x times the log of 4. I have to subtract that to bring it to the left side. I'm going to add the 2 log 5 over to the right side, and I already have a 3 log 4 on that side. So all of the pieces that have x in them are on the left, and everything that doesn't have an x is on the right. Then I need to factor the x out. Since I'm trying to solve for x and it's in two different spots, I need to get that condensed into one. So I'm going to factor an x out. It was multiplied to a log of 5 minus 2 log of 4. I haven't done anything to the right side here. And now I can take this whole piece and divide it to the other side. So x will end up being 2 times log 5 plus 3 log 4 divided by the stuff in the box here, log 5 minus 2 log 4. And all of those are just decimal numbers. So at this point now I can grab a calculator and just type that in. So we have, and you are going to need parentheses when you type this in your calculator so that the whole top is getting divided by that whole denominator. Okay, so parenthesis 2, one sec, I need to slide it over here. Okay. 2 log 5. We have to close off that log 5 parenthesis plus 3 log 4. Close off that log 4 parenthesis, and then close off the whole numerator. Divided by, and then the same thing, parenthesis, log 4, close off the log. Sorry, we wanted log 5, minus 2 log 4, close off the parenthesis, and then close off the parenthesis for the denominator. So our final answer should be negative 6.34. All right, we're going to try a couple more of those so we get those steps down. So step 1 is to take the log of both sides. Step 2 is then to bring the powers out front. Remember that when you're bringing that expression to the front, it is getting multiplied, the whole thing, to the log of 3. On the right, the x plus 1 is getting multiplied all to the log of 7. Our next step is to distribute. So we get 2x times log 3 minus 1 times log 3. On the right, we have x times log 7 plus 1 times log 7. And then we move anything with an x to one side. So I'm going to subtract this piece over to the left. So 2x log 3, I'm going to subtract that x log 7. This piece is going to get added over to that side since it doesn't have an x in it. And then we factor an x out. So x times 2 log 3 minus log 7. And again, I haven't changed anything on this side right now. And then we can divide all of that stuff in parentheses over to the right side. So we're going to have what's on the right side divided by what we're dividing over, which is that 2 log 3 minus log 7. But again, remember on your calculator, when you type a log, it has a parenthesis, so you have to close that off. And then we also want to make sure and put parentheses around the whole top and divide it by that whole denominator. So what I would do is pause the recording and try typing that in your calculator, and then turn it back on and see if you get what we get. All right, so parenthesis log 3, close that off, plus log 7, and then close off the whole numerator, divided by parenthesis 2 log 3, close it off, minus log 7, close it off, and close off the denominator. So we should have 12.11. All right. I would pause the recording and try this whole next one on your own, and then come back and check it. All right, taking log of both sides. Moving our powers to the front when we expand this. Same thing on this side. Then we distribute, so we have 4x log 7 minus 2 log 7. On the right, we have x log 6 plus 1 log 6. And then rearrange our terms so that anything with an x is on the left. That means I'm going to subtract this one over. Anything that doesn't have an x is going to get moved to the right, so I'm going to add that piece over here. I'm going to factor an x out. So we get 4 log 7 minus log 6. And then we can divide. So x will be 2 log 7 plus log 6 divided by 4 log 7 minus log 6. And again, make sure you close off those little parentheses that pop up when we do logs. All right, so for this one, parentheses, 2 log 7 plus log 6. Close off the numerator, divided by parentheses 4 log 7 minus log 6. And we end up with about 0.9485. All right, so that is a technique we can use when we have an exponential equation, different bases on each side, and there's no way to get them to match, and both sides have exponents. The second type that we're going to look at today is how we can use factoring to solve an exponential equation. And if you look at these exponential equations, all of them involve an e. Sorry, the first three involve an e. So we are going to look at using natural logs. But the key here is to notice that it is a trinomial, just like you factored trinomials in the past. So if I had, say, w squared minus 4w plus 3, and I said to solve by factoring, we would factor and split up that w squared, and we'd put 1 in each one. We'd then look at factors of 3 that add up to -4, so we could do a -1 and a -3. And when we check insides and outsides, they add up to that -4w. Okay, so that's that factoring technique. We really have the same idea here. Instead of just a w squared, this is really an e to the x that's being squared, right? Power to a power we would multiply. So our shortcut way of writing that is just e to the 2x. But it's really an e to the x that's getting squared. And notice that we have an e to the x in our middle term. So just like in this first example here, we had a w squared in the first place, and then in the middle position, we just had a w. So we have that same idea. So my e to the 2x is really going to get split up into an e to the x in each parenthesis. And then I factor just like I normally do. Factors of 3 that add up to -4, excuse me, would be -3 and -1. But now each of these have to get set equal to 0. All right, so setting the first one equal to 0, we have e to the x minus 3 equals 0. We're going to add 3 to both sides. And then to solve for x now, I'm going to need to take the natural log of both sides. But the natural log of e to the x is just x. So x ends up being the natural log of 3. On the right equation here, e to the x minus 1 equals 0. We'd have e to the x equaling 1. Again, taking the natural log of both sides, we're going to have x equals the natural log of 1. And you can grab a calculator. We want the natural log of 3. So we're going to have 1.0986 for the first answer. And then, if you don't remember, the natural log of 1 is just 0. So we end up with two solutions, a 1.0986 and 0. All right, let's try that same thing on this second one. Again, our e to the 2x, we want to think of it as e to the x being squared. So we're going to split it and put 1 in each factor. We're going to look for ways to multiply and get 7, but have them add up to -8. So we can do -1 and -7. And then we're going to set each of those equal to 0. Adding the 1 over, we have e to the x equaling 1. Now taking the natural log of both sides. Natural log of e to the x is just x. And we just found out that the natural log of 1 is 0. For our second equation, we would have e to the x having to equal a 7. Taking the natural log of both sides, we have x equaling the natural log of 7. And if we punch that in our calculators, we end up with 1.9459. All right, so go ahead and pause the recording and try number 3. All right, let's check what you did. We should have an e to the x in each factor. Numbers that multiply to be -24 but add up to 5 We could have a positive 8 with a negative 3. Setting them each equal to 0, we'd have e to the x having to be a negative 8 and e to the x having to be a positive 3. Taking the natural log of both sides, you should end up with x being the natural log of negative 8 or the natural log of 3. Now we've already done the natural log of 3. We said that was 1.0986. But when you tried to do the natural log of negative 8, you probably ran into some trouble. All right? It's non-real. Remember how our log graphs kind of came up along the y-axis and then curved off to the right? We weren't able to take the log of a negative. So this part here would have no solution. Our only answer would be that one. All right, the last one we're going to look at today, similar setup. Instead of an e, we have a base of 4. So again, think of 4 to the 2x as 4 to the x getting squared. So we're going to split it up and we're going to put a 4 to the x in each parenthesis. We're going to look for ways to multiply to be negative 30 and add to be a 1. Now, keep in mind that 4 to the x is this piece that we've split into. So our middle term has to have a 4 to the x, and we only have one of them. So we are really looking for numbers that multiply to be negative 30, but add up to 1. So we would need a positive 6 and a negative 5. Setting each of those equations or each of those factors equal to 0, this would give us that 4 to the x would have to be a negative 6. Over here, 4 to the x minus 5 is 0 when 4 to the x equals 5. And now we can take the log of both sides. There's no e in this one, so we can use natural log. We don't have to. We can just use a common log. Log of 4 to the x equals the log of negative 6. But right here, you're taking the log of a negative, so we don't even have to finish that one. It's not going to work. All right, we cannot take the log of a negative number. On the other one, we've got log of 4 to the x being common log of 5. Our x, remember, gets expanded into the front. So this is x times the log of 4, equaling the log of 5. And then solving, we would divide out our log 4. So common log of 5 divided by the common log of 4. Again, typing that into our equation, we should end up with x being about 1.161. All right, so two types of questions again. Solving when we have different bases, both to powers, and solving when we can factor to do that. So our assignment today, we're going to take off the second part. We're only going to have you do this first piece, page 490, numbers 41 to 48. I'm only giving you 8 questions, but I expect you to show me all the lovely work just like we've done in our notes today.